Tired of cold calling? Introducing Lucia, the easiest, most accurate way to prospect. Simply sign up for free, and congrats! Now you can reach more than 50 million direct dials. How? Easy! Find your target on LinkedIn and click on Show Contact to get the prospect's number and email. You can even bulk enrich multiple prospects in one click and save them directly to your CRM. Lucia, start for free!
जो चीजें हैं ना वो थोड़ी सी पेचीदा है, आपके लिए नई हो सकती है, लेकिन मैं समझाने की कोशिश करूंगा बहुत ही इजी तरीके से और मुझे लगता है आपको ये इजीली समझ में आ जाएगा। तो पूरा वीडियो देखिएगा, स्टेप बाय स्टेप मैं बताने की कोशिश कर रहा हूं और बहुत ही अगर आपने वो नींव समझ ली, वो चीजों को इजीली समझ लिया तो 5 मिनट के अंदर आप वो कैमरा को ऑनलाइन कर सकते हैं, यूट्यूब पर लाइव स्ट्रीम कर सकते हैं। ओके, तो चलिए वीडियो को शुरू करते हैं। और इस वीडियो को शुरू करने से पहले आप सब लोगों को बता दूं कि इंस्टाग्राम पर हर रविवार रात को 9 बजे मैं आता हूं लाइव, जहां पर मैं बात करता हूं आपकी प्रॉब्लम से रिगार्डिंग और निकल के आते हैं कुछ बेहतरीन सॉल्यूशंस। और इसके साथ में एक चीज और ऐड करना चाहूंगा कि अब से हमारी जो वेबसाइट है askbharatjain.com वो लॉन्च हो चुकी है। कई लोग मुझसे मिलना चाहते हैं, मुझसे बात करना चाहते हैं, उनके पास में बहुत सारे प्रोजेक्ट हैं, तो मैं उनकी हेल्प कर सकता हूं, उनके प्रोजेक्ट से रिलेटेड मैं हेल्प कर सकता हूं, उनके जो प्रॉब्लम्स आ रही है उससे रिलेटेड मैं हेल्प कर सकता हूं, उनको स्पाई कैमरा के जो गैजेट्स हैं उससे रिलेटेड कंसल्टिंग दे सकता हूं, मैं हेल्प कर सकता हूं, उनके बिजनेस को कंसल्टिंग दे सकता हूं। तो विजिट करिए आज ही जो है हमारी वेबसाइट askbharatjain.com, जहां पर आपको मिलेगा मेरा अपना पर्सनल टाइम। तो शुरू करते हैं आज के हमारे इस इंटरेस्टिंग वीडियो। तो YouTube पर हमें सीसीटीवी कैमरा को ऑनलाइन करना है, तो हम कौन से कैमरास कर सकते हैं। सबसे पहली बात, आज का जो वीडियो है वो बना रहा हूं मैं स्पेशली हिकविजन पर, और मेरी जो ट्राई थी वो हिकविजन पर चल रही थी और हिकविजन पर मैं इसमें सक्सेस हो गया। तो आगे आने वाले टाइम में जो अलग ब्रांड्स है उसके ऊपर मैं ट्राई करूंगा, अगर उसमें भी सक्सेस हो जाता है तो उसका भी वीडियो आप तक जरूर मिल जाएगा। तो आज की जो ब्रांड है वो है हमारी हिकविजन की। तो हिकविजन के अंदर आप हिकविजन का जो लेटेस्ट डीवीआर है वो आप कर सकते हैं, एनवीआर है वो आप कर सकते हैं, और जो आईपी कैमराज हैं वो आप कर सकते हैं। जो रिकमेंडेबल है वो ये है कि अगर आप आईपी कैमरा, अगर सिंगल एक कैमरा जो है वो अगर आप लाइव स्ट्रीम करें तो ज़्यादा बेटर होगा। आप इसके अंदर ऑडियो वाला कैमरा भी कर सकते हैं, ताकि आप जहां पर इस कैमरे को लाइव करना चाहते हैं, फॉर एग्जांपल ज़्यादातर आप लोगों को पता होगा कि ये जो लाइव करने की जो हमारे पास में रिक्वायरमेंट आती है वो रिक्वायरमेंट होती है ज़्यादातर मंदिरों की, ज़्यादातर इवेंट, ऐसे कोई इवेंट जहां पर जैसे गरबा हो गया, इस तरह से जो कुछ इवेंट किए जाते हैं हमारे देश में, वहां की और भी बहुत सारी चीज़ें जो आपको शायद पता होगा। तो वहां पर आप एक आईपी कैमरा लगाकर अगर आप उसको लाइव स्ट्रीम करते हैं तो इजीली मोस्ट ऑफली सब लोग देख पाएंगे। लेकिन एक चीज़ का हमेशा ध्यान रखिएगा कि जितने ज़्यादा लोग देखेंगे उतना ये चीज़ हैंग होगी, क्योंकि उतनी अपलोड स्पीड देना और फिर एक साथ में इतना ट्रैफिक आ जाना तो वो आपके लिए थोड़ा सा प्रॉब्लमेटिक हो सकता है। ये एक अलग टाइप का सॉल्यूशंस है। और इसके बाद में जो ब्रॉडकास्टिंग लेवल की जो चीज़ें होती है वो आगे आने वाले वीडियोस के अंदर हम बताएंगे। इसके अंदर पेड होता है कि आपको एनुअल सब्सक्रिप्शन लेना पड़ेगा, ताकि जितने भी लोग हैं बहुत ज़्यादा, अगर आप लाइव करना चाहते हैं वो कैमरा बहुत सारे लोग उसको व्यू करना चाहते हैं तो फिर वहां पर उनको प्रॉब्लम ना आए, तो उसके लिए ब्रॉडकास्टिंग होती है, स्टैटिक आईपी लेना पड़ता है और वो बहुत सारी चीज़ें होती हैं। लेकिन आज का जो वीडियो है वो है स्पेसिफिक, आपको इसमें कुछ भी नहीं लेना है, ना आपको इसमें स्टैटिक आईपी की रिक्वायरमेंट है, ना आपको इसके अंदर आपको कोई ब्रॉडकास्टिंग लेने की रिक्वायरमेंट है। आप इजीली आप कोई भी कैमरे को, हिकविजन के आईपी कैमरा को आप लाइव कर सकते हैं यूट्यूब पर। सो आज जो मैं कैमरा यूज कर रहा हूं वो है हमारा ये हिकविजन का एक डॉम कैमरा आईपी, और इसका जो मॉडल नंबर है वो है हमारे पास में DS2CD3323GOEI, एक प्रोजेक्ट सीरीज का कैमरा है। इसके अंदर ऑडियो भी है, ताकि मैं आपको ऑडियो स्ट्रीमिंग भी करके बताने वाला हूं कि कितना अच्छे तरीके से ऑडियो स्ट्रीम भी हो जाता है। तो सबसे पहले तो इस कैमरे को जो है वो आपको आपके नेटवर्क के अंदर कनेक्ट कर लेना है। ऑलरेडी मेरी जो आईपी से कैमरा की जो सीरीज चल रही है उसके अंदर मैंने आपको बताया ही है कि किस तरह से आप इसको अपने नेटवर्क में लेकर और इस कैमरे को ओपन कर सकते हैं। अगर आपने अभी तक वो वीडियो नहीं देखा हो तो आई बटन में लिंक दे रहा हूं, वहां पर जाकर इस वीडियो को ज़रूर देख लीजिएगा। तो चलिए हम इस कैमरा को हमारे पीसी पे कनेक्ट करते हैं और आगे की जो भी सेटअप्स है वो है हमारे पीसी से रिलेटेड। तो चलिए वहां पर चलते हैं। तो जो हमारा आईपी कैमरा है हमने उसको कनेक्ट कर लिया है हमारे राउटर के साथ में, और न्यू कैमरा है तो सबसे पहले हमें जाना होगा एसएडीपी में। बहुत ही सिंपल सा मैं यहाँ पे आपको एक्टिवेट करके बता रहा हूँ। तो यहाँ पर ये जो हमारा कैमरा है DS2CD3323GOEI अभी इनएक्टिव स्टेज पर है, मतलब न्यू कैमरा है जिसको हम अभी यूट्यूब के ऊपर लाइव स्ट्रीम करने वाले हैं। सो हम इसको यहाँ से एक्टिव कर लेते हैं, और एक्टिव करने के लिए हमें यहाँ पर हमारा जो पासवर्ड है वो इनपुट करना पड़ेगा। और हमने जो हमारा कैमरा है वो यहाँ पर कर दिया एक्टिवेट, और यहाँ पर मुझे इस कैमरे को हमारी जो सीरीज़ है उसके अकॉर्डिंग हमें यहाँ पर नाम भी देना होगा। ये कुछ सिक्योरिटी क्वेश्चंस हैं, आप आपके एंड से दे सकते हैं यहाँ पर। और जो हमारा कैमरा है यहाँ पर आप देख पा रहे हैं कि ये एक्टिव हो चुका है। यहाँ पर मुझे जो आईपी है वो मुझे अपनी सीरीज़ में देना पड़ेगा। जो मेरे राउटर की जो सीरीज़ चल रही है वो चल रही है 0 डॉट, और मैं इसको दे देता हूँ एक बार 210, ठीक है। और यहाँ पर बाकी और मुझे कुछ गेटवे है, उसको मुझे राउटर का जो गेटवे है हमारा वो मुझे दे देना है, और बाकी इसमें कुछ नहीं करना है। यहाँ पर सीधा जो भी मैंने पासवर्ड डाला था वो पासवर्ड करके मॉडिफाइड कर देना है। पैरामीटर मॉडिफिकेशन कंप्लीटेड, मतलब यहाँ पर मेरा जो कैमरा है वो एक्टिव हो गया है। तो अभी आपको जाना है सीधा इंटरनेट एक्सप्लोरर में, जहाँ पर हम इस कैमरे को ओपन करेंगे। इस कैमरे का हमारा जो आईपी है वो था 192.168.0.210 210। ये देखिए यहाँ पर बहुत ही सिंपल से प्रोसेस में मैं आपको थोड़ा बता रहा हूँ। ये जो भी प्लगइन्स आएंगे वो आपको अपडेटेड रखने हैं, अगर नहीं है तो आप इसको इस तरह से डाउनलोड कर सकते हैं। वेब कंपोनेंट्स हैं। यहाँ पर जो हमारा जो कैमरा है उसका जो यूज़र नेम है वो है एडमिन, आप इस चीज़ को अच्छे से याद रखिएगा। और जो पासवर्ड रखा है मैंने वो रखा है CCTV@123, ओके। और ये मैंने यहाँ पर लॉगिन किया। अब ये देखिए आपके सामने जो हमारा कैमरा है वो लॉगिन है, और ये हम इस तरह से कुछ देख पा रहे हैं। अब हमें जाना है यहाँ पर सीधा कॉन्फ़िगरेशन में। जो आपको सेटिंग्स ध्यान रखनी है वो आप नोट करते जाइएगा कि मैं यहाँ पर क्या क्या करने वाला हूँ। सो कैमरा के अंदर आपको ध्यान में रखना है सबसे पहले आपका यूज़र नेम, आपके सिस्टम का पासवर्ड, ओके। दूसरा यहाँ पर आपको जो इम्पोर्टेंट रोल प्ले करने वाला है वो है आपका
Tired of cold calling? Introducing Lucia, the easiest, most accurate way to prospect. Simply sign up for free, and congrats! Now you can reach more than 50 million direct dials. How? Easy! Find your target on LinkedIn and click on Show Contact to get the prospect's number and email. You can even bulk enrich multiple prospects in one click and save them directly to your CRM. Lucia, start for free!
नेटवर्क में आपको जाना है, और नेटवर्क में आप एडवांस सेटिंग में जाएंगे। एक आपको यहाँ पर आपका जो ऑनविफ है उसको एक्टिवेट कर देना है। ये आपका ऑनविफ यहाँ पर एक्टिवेट हो गया। दूसरा आपका यहाँ पर जो वीडियो है, आप ऑडियो वीडियो में गए तो वीडियो है उसके अंदर स्ट्रीम जो टाइप है अभी फिलहाल यहाँ पर से वीडियो स्ट्रीम है। अगर आपका कैमरा ऑडियो भी सपोर्ट करता है तो आपको यहाँ पर वीडियो एंड ऑडियो स्ट्रीमिंग को भी ऑन कर लेना है, कुछ इस तरह से, ठीक है। अब यहाँ पर आप वापस चले जाएंगे नेटवर्क में आपके, और नेटवर्क में जाने के बाद में आपको जाना है यहाँ पर पोर्ट में, और पोर्ट में आपको यहाँ पर जो ज़रूरत पड़ेगी, जो मेन रोल प्ले करता है स्ट्रीमिंग के अंदर, वो होता है आपका 554, ठीक है। अब आपको एक तो ये याद रखना है 554, मतलब आपने यहाँ पर क्या क्या नोट किया, आपका यूज़र नेम है कैमरे का एडमिन, आपका पासवर्ड जो है कैमरे का वो है हमारा यहाँ पर CCTV@123, और आपका जो RTSP पोर्ट है वो है आपका 554। ओके, ये 3 चीज़ें आपको कैमरे के अंदर आपको याद रखनी है, जो आपके पास में नोट होनी चाहिए। ये हो गया आपका काम। अब आपका जो हिकविजन के अंदर RTSP जो लिंक बनता है वो लिंक होता है आपका RTSP://admin, एडमिन आपका यूज़र नेम कॉलन पासवर्ड आपका, फिर वापस से @ फिर आपका कैमरे का IP एड्रेस या फिर आपके DVR का IP एड्रेस या फिर आपके NVR का IP एड्रेस, फिर वापस से डबल कॉलन, फिर आपको लिखना है यहाँ पर आपका RTSP पोर्ट, फिर आएगा आपका स्लैश, फिर आएगा स्ट्रीमिंग, फिर आएगा स्लैश चैनल्स, फिर आएगा स्लैश, फिर आएगा 101। सो ये आपका हो गया RTSP लिंक। अब इस RTSP लिंक को आप कर लीजिए कॉपी। अब मुझे ये देखना हो कि ये जो मैंने लिंक बनाया है वो सही है या नहीं है, तो इसके लिए आपके पीसी के अंदर, आपके लैपटॉप के अंदर ज़रूरत पड़ेगी VLC प्लेयर की। सो हमने इसको कर लिया कॉपी, और अब आप जाएंगे आपके VLC प्लेयर में। तो अभी आपको ओपन करना है आपका VLC प्लेयर। VLC प्लेयर में आपको जाना है मीडिया में। मीडिया में जाने के बाद में आपको ओपन करना है ओपन नेटवर्क स्ट्रीम। यहाँ पर आपका जो RTSP जो लिंक बनाया है आपने उसको कर देना है पेस्ट, और उसको यहाँ पर करना है प्ले। अगर यहाँ पर आपका कैमरा ऑन हो गया तो फिर आपका जो लिंक है वो आपका एकदम सही बना है। यहाँ पर ऑडियो भी आ रहा है और वीडियो भी आ रहा है, ठीक है। तो यहाँ पर जो आपने लिंक क्रिएट की है वो एकदम एक्चुअल सही है, कोई प्रॉब्लम नहीं है। अब आपको ये चेक करने के बाद में आपके इस पीसी के अंदर रोल आता है एक सॉफ्टवेयर जिसका नाम है OBS स्टूडियो। ये एक ओपन प्लेटफॉर्म है OBS के लिए, यानी कि लाइव स्ट्रीमिंग करने के लिए इसका यूज़ किया जाता है। फ्री सॉफ्टवेयर है। इसका जो लिंक है वो मैं आपको डिस्क्रिप्शन में दे रहा हूँ, वहाँ से जाके आप इसको इंस्टॉल कर सकते हैं, या फिर गूगल में भी लिखेंगे OBS स्टूडियो तो आपको मिल जाएगा। सो आपको ओपन करना है यहाँ पर आपका OBS स्टूडियो। सो आपको आपके पीसी के अंदर OBS स्टूडियो इंस्टॉल करने के बाद में इसको ओपन करना है, और ओपन करने के बाद में आपको जाना है यहाँ पर सोर्स में। सोर्स में आपको ऐड करना है मीडिया सोर्स। मीडिया सोर्स में फॉर एग्जांपल यहाँ पर मैंने नाम ऐसे ही दे दिया RTSP, उसको किया मैंने यहाँ पर ओके। और यहाँ पर आपको लोकल फाइल के ऊपर से क्लिक को हटाना है, और यहाँ पर इनपुट के अंदर आपको आपका जो स्ट्रीमिंग का जो था आईडी था, आपकी जो स्ट्रीमिंग की जो लिंक है थी वो यहाँ पर आपको पेस्ट कर देनी है, और उसको पेस्ट करने के बाद में कर देना है यहाँ से ओके। इतना काम आपका इसके अंदर था। ये देखिए आपके सामने वो जो लिंक था, वो जो आपका कैमरा है उसकी स्क्रीन यहाँ पर आपके पास में आ जाएगी। इसको आप जितना बड़ा या फिर छोटा या फिर जैसे भी आप रखना चाहते हैं वो यहाँ पर रख सकते हैं। प्लस OBS स्टूडियो के बारे में भी आप समझ लीजिएगा थोड़ा सा, YouTube के ऊपर आपको बहुत सारे वीडियोस मिल जाएंगे। तो इस ये जो आपका लाइव स्ट्रीमिंग है उसके आसपास की जो जगह है ना, वहाँ पर आप कोई एडवर्टाइजमेंट भी PNG फाइल को बनाकर उसमें ऐड करके कर सकते हैं। तो उसमें अभी फिलहाल हम नहीं जाएंगे, वो पूरा एक OBS के ऊपर का जो वीडियो है वो आपको कई सारे वीडियोस मिल जाएंगे, आप YouTube पे जाके देख सकते हैं। अब आपके पास में इतना करने के बाद में एक YouTube चैनल होना चाहिए, और उस YouTube चैनल का जो लाइव स्ट्रीमिंग है वो आपका ऑन होना चाहिए। ओके, अगर नहीं है तो आप उसको वैलिडेट करेंगे तो वो हो जाएगा। कैसे होता है उसके लिए भी आपको YouTube के ऊपर अलग अलग वीडियोस मिल जाएंगे। ओके, तो यहाँ पर मेरे पास में फॉर एग्जांपल YouTube चैनल है, और उस YouTube चैनल का मेरा जो लाइव स्ट्रीमिंग है वो भी ऑन है। ठीक है, तो हम उसी पे चलते हैं सीधा, ताकि आपको समझने में इजी रहे। तो आपको जाना होगा यहाँ पर जहाँ पर हम लोग लाइव करने के लिए जाते हैं, तो गो लाइव, आप यहाँ पर जाएंगे। अब यहाँ पर आपको जो ज़रूरत पड़ती है वो है आपकी इस की। ये जो स्ट्रीम की है ना, ये बहुत ही इंपॉर्टेंट है और ये आप वैसे किसी और के साथ में आपको शेयर नहीं करनी चाहिए। सो इसको आप यहाँ से कर लीजिए कॉपी। ओके, ये मेन स्ट्रीम की होती है कि जो स्ट्रीम करती है आपके यूट्यूब का जो है उसको लिंक कर देती है कोई अदर सॉफ्टवेयर के साथ में। ओके, सो हमने इसको यहाँ पर कर लिया, इस की को कॉपी। और आपका जो OBS है उसके अंदर आपको जाना है सेटिंग के अंदर। सेटिंग के अंदर आपको जाना है यहाँ पर स्ट्रीम में, और यहाँ पर ये जो देख रहे हो ना, ये जो स्ट्रीम की है वहाँ पर इसको आपको कर देना है पेस्ट। दैट्स इट। और इसको यहाँ से कर लेना है आपको ओके। इतना आपने कर लिया, आपका काम हो गया। और यहाँ पर आप देख रहे हैं स्टार्ट स्ट्रीमिंग, और यहाँ पे जैसे ही आप क्लिक करेंगे आपका ये जो कैमरा है वो लाइव स्ट्रीम हो चुका है। यहाँ पर आप ये ग्रीन देख रहे हैं kbps। ओके, और आपको जो प्रूफ है वो मैं आपको दिखा देता हूँ अभी कि किस तरह से वो लाइव स्ट्रीम हो गया है। ये रहा वो कैमरा आपका लाइव स्ट्रीम, और ये हमारी जो लाइव स्ट्रीम है वो शुरू हो चुकी है। आप ये देख रहे हैं, जस्ट इसको हम थोड़ा सा मूव करते हैं। अब ये जो भी है, जितना भी मैं मूव कर रहा हूँ इस कैमरे को, वो डिपेंड करता है कि हमारी जो नेटवर्क की स्पीड कैसी है उस पर। और ये इजीली आप इस तरह से लाइव स्ट्रीम देख सकते हैं। ये आप देख पा रहे हैं, दिस इज द लाइव स्ट्रीम। अब ये कंप्लीट डिपेंड करेगा कि आपके नेटवर्क की स्पीड कैसी है और उन्हीं सब चीज़ों पर। सो बस ये जो वीडियो है उसके अंदर इतना ही था। अभी आपको मैं नोट करवा रहा हूँ जो आपको ज़रूरत पड़ेगी। आपको चाहिएगा, वापस से हम लेके एक बार रिवाइज कर रहे हैं, आपको चाहिएगा एक आपका लैपटॉप या फिर एक कंप्यूटर। उसके अंदर आपको चाहिए OBS सॉफ्टवेयर इंस्टॉल किया हुआ, जिसका लिंक मैं डिस्क्रिप्शन के अंदर दे रहा हूँ। एक IP कैमरा आपको चाहिएगा। आपको एक YouTube चैनल चाहिए जिसके अंदर आपका लाइव स्ट्रीम आप जिसके अंदर कर सकते हो, इनेबल हो। और एक आपके PC के अंदर VLC प्लेयर इनेबल्ड होना चाहिए। बस इतनी 4 चीज़ें चाहिए, और उसके थ्रू आप RTSP पोर्ट के थ्रू आप कैमरा को, DVR को या फिर NVR को हिकविजन के लाइव स्ट्रीम कर सकते हैं। सो कैसा लगा हमारा आज का ये वीडियो? मुझे लगता है कि आपको आज का जो हमारा वीडियो है वो काफ़ी पसंद आया होगा। और अगर आपको हमारा ये वीडियो पसंद आया हो तो हमारे इस वीडियो को लाइक, चैनल को सब्सक्राइब करिए, दूसरों के साथ में शेयर करिए। मिलते हैं अगले वीडियो में कुछ नई टेक्नोलॉजी, नए गैजेट्स और इसी तरह की बहुत सारी नई नई चीज़ों को लेकर। तब तक आप सब लोगों का बहुत बहुत धन्यवाद हमारे इस वीडियो को देखने के लिए। जय हिंद।
Do you want to live stream your security camera feeds to Facebook, YouTube, Twitch, or anywhere else? Well, you can. Whether you have an IP security camera or even an analog system, in today's video, we're going to show you how you can live stream your security camera feeds using the free open source broadcasting software, OBS. A couple of months ago, we started a brand new private Facebook group for our dealers. On that page, we've been streaming various cameras around our offices via Facebook Live. We've gotten a lot of great feedback from that. I know people are really enjoying it, but we've also gotten a lot of questions on how we are doing that. Well, it's actually pretty easy, and in today's video, I'm going to show you 3 different methods for live streaming your security cameras via OBS. You can get started streaming your cameras right away with very little setup, and here is everything that you're going to need. First and foremost, you're going to need a security camera. Now, you probably already have this. If you don't, then why are you even watching this video? It doesn't really matter if your camera is IP or analog, just keep in mind the type of your camera when we get to the 3 different methods. Next, you will need a computer with an internet connection and relatively fast upload speeds. Now, the minimum upload speed here is going to be around 3 or 4 megabytes per second, depending on the platform that you're going to be streaming on. But the faster the upload speeds, the better. Next, you're going to need OBS installed on that computer. Now, OBS stands for Open Broadcaster Software, and it's pretty much the standard for streamers everywhere. It's simple to use, it's got a ton of features, and best of all, it is totally free. So click the link in the description and go ahead and download OBS onto your computer. Next, depending on the method that you use to stream your cameras, you are going to need a couple of additional items. You're going to need either your IP camera's RTSP address, or you're going to need an internet browser, and for the third option, you're going to need a video recorder and an HDMI capture card. So how do you know which method is best for you? Well, let's find out. Like I've already mentioned, we're going to show you 3 different ways to live stream your cameras. The first way is a direct live stream straight from your camera using the RTSP address. The second option is going to be screen recording your camera with a web browser. And the third option is going to be streaming your recorder feeds with an HDMI capture card. First, let's talk about your RTSP address. This is probably the simplest method that is going to get you up and running in no time. RTSP stands for Real-Time Streaming Protocol. And what this protocol does is it allows your security camera to communicate with third-party devices and applications and servers. In our case, the third party is going to be OBS. And it's just a really simple and seamless way to stream your cameras. It's fast, it's easy to set up, and you don't need any additional hardware. There's no middleman, it's just your security camera and OBS. But there are a few drawbacks to this method. First, the RTSP feed really isn't that stable, and so you might experience some lag, especially if you're streaming at the mainstream. If it's like a 4K camera with high FPS, you're going to experience some lag and some low latency, and you might have some other video issues. Furthermore, this method only works with IP cameras. If you have an analog camera, there is no way for you to get an RTSP feed straight from the camera without going through a DVR. The last drawback here is that you're only streaming raw feeds directly from the camera. So if you have any intelligent events or any kind of markers on the screen, you're not going to be able to see that through the RTSP feeds. The next method is also really simple. This involves just pulling up your web browser on your computer, typing in the IP address and getting the live view, then simply just capturing your screen or that particular window and streaming that. This is another really easy method, and it's a good way for you to show off intelligent markers if you have something on the screen like UniView's deep learning cameras, for instance. But this does take up more real estate on your computer. You won't really be able to use your computer if you are recording the full screen, but this could work if you just have a PC that is fully dedicated to your security cameras. If you wanted to pull this up and set it there for a while, you totally could. And the last method is going to be streaming with an HDMI capture card. An HDMI capture card is simply a device that connects to your computer and allows you to run an HDMI input directly into OBS. There are lots of options for this on the market, ranging from $20 to a couple $100. The one I'm using back here is a Hauppauge HDMI device. We also have an Elgato capture card floating around here. We use these quite a bit here for recording NVR interfaces, taking screenshots for blog posts. Since we already have these on hand, we do use them often for live streaming. With this, you can use either an IP camera or an analog camera as long as it's connected to a DVR with an HDMI output. And it doesn't take up extra real estate on your computer because the streaming is coming from your NVR. Once you've picked the method that you're going to use, we're ready to jump onto the computer and get OBS set up and ready to go. So once you click the link in the description below and download OBS, it will take you through a startup wizard that will help you adjust some of the settings based on what you're going to be doing with OBS. This is not a full OBS tutorial. There are plenty of resources all over the internet if you want to get a more full grasp on what this program can do. But just to get you up to speed, if you've never opened OBS before, this screen right here in the middle is the monitor. It's going to show us whatever is being streamed or recorded. Right now this is black because we don't have any sources. Which brings us down here to this panel, which is the sources panel. If we click the plus button, this is going to let us add a ton of different sources depending on what we want to be streaming or recording. All right, in settings, first let's jump down in here to the video tab. And you can see that we have our base canvas and our output resolution, as well as our frame rate down here. So right now we have the base resolution as 1920 by 1080. However, I know a lot of times we have security cameras that are above this 1080p resolution. Personally, I don't recommend streaming higher than a 1080p resolution, simply because most platforms are going to reduce the video quality anyway during a live stream. Plus, the higher the resolution, the lower quality the stream is going to be, especially if you have lower upload speeds. So I'm going to leave this base canvas resolution as 1920 by 1080, and the output resolution right now is also 1920 by 1080. If you have lower internet speeds, you can reduce this to something like 1280 by 720. And what that's going to do is take your 1080p video and stream it at a lower resolution. Again, the lower the resolution, the higher quality your stream is going to be, the less lag you're going to have. So unless you have really good upload speeds, I recommend switching this down to 1280 by 720. Now we have our frame rate down here. This pretty much is going to depend on the frame rate of your camera. You can choose anything you want here. If you're streaming a camera that is 30 frames per second, for instance, you can change the frame rate to 30. Next, I'm going to hop up here to output, and this is where we actually adjust the quality of our stream. We have two different modes here. We have simple settings and advanced settings. For this tutorial, we are going to stay here on the simple menu. So, bitrate. This is going to be an important number. This is the amount of data that you are streaming every second. So the higher the bitrate, the higher quality the stream is going to be, the less lag, all that kind of thing. But there are a couple of catches here. First, you're going to want to look up the bitrate requirements for whatever platform you're streaming on. Again, we stream mostly on Facebook, which does cap out at 6,000 kilobytes per second. In my understanding, this is true for most platforms, so I just always leave this on 6,000. Theoretically, we could increase this to 8192 kilobytes per second, which is what we typically recommend for 4K cameras. But in this case, when we're streaming to something like Facebook, that extra bitrate really isn't going to help us, and in the long run, it might end up hurting us. So just keep this at 6,000 unless you know that the platform you're streaming on is compatible with higher bit rates. But here's the other catch. We are going to need to keep our upload speeds in mind for this, because we don't want our video bitrate to exceed our upload speeds. For instance, I can have this at 6,000 kilobytes per second because my upload speed is about 10,000 kilobytes per second, or 10 megabytes per second. So before you set your video bitrate, you are going to want to run a speed test so you know exactly what your upload speeds are. That way, if you only have like a 3 or a 4 megabyte per second upload speed, you'll know that you need to keep your video bitrate at around 3,000 or 4,000 kilobytes per second. And now I will throw a handy chart up here on the screen so you can see exactly what your limitations are going to be if you do have to have a lower bitrate. Now, this is what we have found as acceptable configurations per upload speed. Your results may vary, so if this doesn't work for you, feel free to play around with these numbers a little bit. And while you're looking at that and crunching those numbers, I'm going to have a sip of coffee. Okay, you guys ready? Feel free to pause it if you're still looking at that chart. Otherwise, we are moving on. I'm going to completely ignore audio bitrate here because we're not streaming audio, we're simply streaming the video from our cameras. If you do have a camera that has a built-in mic, then you will be able to pull that audio stream in as well. But honestly, just leave this at the default 160. You're not going to need anything more than that. And at the bottom, we're just going to click OK. So far, everything that we've done in OBS is going to be the same regardless of the method of streaming that you've chosen. Now, as we start to build up our stream and set up our media sources, this next part is going to be different for each method. So first, let me show you how to pull in your IP security camera's RTSP feed. The first thing we're going to do is come down here and click on the plus button to add a new source. This source is going to be a media source. So we will click that. You can name it whatever you want. I'm going to name it IP security camera and click OK. And now we have the properties for our new media source. By default, local file is selected, but we don't want local file because we are going to be streaming via the network. Network buffering, we are going to turn this up to 8, and reconnect delay, we're going to turn this all the way down to 1 second. Feel free to check use hardware decoding when available if you do have some good hardware in your computer. Now we just need to add the input. Now this is going to be your RTSP address. The RTSP address is going to depend on the type of camera that you're going to be streaming. For instance, the camera that I have today is a UniView camera, so I'm going to type in the UniView specific RTSP address. And here is what that looks like. Now it may look confusing at first, but don't let this scare you. All you need to do is swap out those color-coded variables with your own information. Your username, your password, your IP address, your RTSP port, which I will show you how to find momentarily, and your stream. Most of the time this is going to be 0 for your main stream. However, you can also pull in the substream if the main stream is having video issues. The example there is what this might look like if my camera was on the IP address 192.168.1.180, and in this instance it would be pulling in the substream. We can also use the RTSP stream to pull in cameras off of an NVR. This is what that would look like for Uniview. In this example here, we would be streaming the substream of the third channel of the NVR found on 192.168.1.180. Now that's Uniview. At this time we do carry two other product lines, R series and H series. So let me show you what this would look like with those cameras. First, here is an R series camera. It's a lot simpler than the Uniview RTSP feed. All you need here is your IP address, your RTSP port, and the number there for your stream. Again, 0 for main and 1 for sub. If you want to stream cameras off of an R series NVR, all you have to do is swap out that C1 with whatever channel you'd like to stream. Again, in this example, we are streaming the third channel. Finally, if you have an H series camera from us, or even if you have a Hikvision camera, this is the RTSP address that you'll type in. The only difference with H series is that instead of 0 for main and 1 for sub, our stream variable would be 01 for main and 02 for sub. And again, if we are streaming an NVR, we can swap out that 1 at the end for whatever channel we'd like to stream. And once again, in this example, we are streaming the substream of channel 3. If you have a camera from another brand, you can always try one of these to see if it works. If you're still having trouble, you may just need to contact your distributor to figure out what the specific RTSP address is for your cameras. So here is the camera that I'm going to be streaming today. I'm going to come in here and click Setup. I'm going to click Network and Port. Under Port, we can see our RTSP port is 554. That's the default for most cameras. If you have an R series or an H series camera, it's probably also going to be 554, but it's always nice to double check. So in input, here is the RTSP address that I'm going to type in. First, and this is going to be the same for pretty much any IP camera, RTSP://. Next, we are going to add in our login credentials, which is for this camera, admin is the username, then :1234567A ! After this, we are going to hit the @ and then type in the IP address of our camera, which in this instance is 192.168.122. After the IP address, we are going to pop in another colon and type the RTSP port number, 554. Then /media/video1. And that's all that we need to type in here, and we are going to click OK. And there we go. Our RTSP was pulled into OBS, and you can see that since we do have a 1080p base resolution, in other words, this monitor right here is 1080p, we do have some adjustments to make because the security camera that we're streaming is higher than 1080p. So I'm going to grab these resizing handles here, and I am just going to drag the security camera down to fit inside this window. We're downscaling the security camera to 1080p, and then once we stream it, remember we did set our stream resolution to 720p, so it's going to downscale it even more. But now this camera is ready to stream. Let me show you another way of getting this camera in. So we're going to come in here to Add Media Source. We're going to click Display Capture and click OK. Now we can either capture the cursor or not. I'm going to unclick that just so our cursor is not floating around on the screen somewhere. This works best if you have two monitors. I don't have two monitors, so once I minimize this, I'm not going to be able to see what we're recording. But if I kind of drag the window out of the way there, you can kind of see, let's click Live View and OBS. So you can see that I'm able to stream my screen here with all of the intelligent markers available. This does have the downside of taking up real estate on your computer. Again, unless you have a second monitor, which is nice to have for something like this. Or, as I mentioned earlier, if you do have a dedicated computer just for your security cameras, you could do that as well. But the way I like to do this is by streaming my NVR. And to do that, again, I have the HDMI capture card connected here. I have my NVR plugged into that capture card. So now I'm just going to add that capture card as a video source. And to do that, I'm going to click Add, come down here to Video Capture Device, and we can name this NVR. I'm going to click OK. And here we have the device set as the Hauppauge Sienna video capture device. Whatever your video capture device is, you'll be able to find that here. And there we go. That is my NVR's interface popping up here. And I'm just going to click OK. I'm going to leave everything at the default. And now I can stream my NVR. So I'm just going to double click the window here for our IP camera, and that's going to make it full screen. Once I stop moving that mouse around, that little menu is going to go away. There we go. And now I have my IP camera streaming through the NVR. And because we do have those intelligent markers set up on the NVR, we are able to stream those as well. This is my favorite method of streaming an IP camera because I don't have to worry about the RTSP feed cutting out. This is a lot more stable, a lot less laggy, and easier to control. But again, while this is streaming, you can't really access your NVR from the HDMI interface without that showing up on the stream as well. So keep that in mind. And that's pretty much it. Depending on which method you've chosen, you are now all set up and ready to go. You can come in here to settings and to stream. And this is where you will connect OBS to whatever platform you're streaming on. Again, we have Facebook Live set up here. So we would pull our stream key in here, which changes every time. So we have to copy and paste each time we want to go live. And then we simply start streaming. I know this was a lot of info, so if you guys have any questions, please feel free to leave those down in the comments below or reach out to us, give us a call, send us an email. We're always happy to help you out with stuff like this. Thank you guys for watching this video, and I will see you in the next one.
Hey everyone, welcome to my channel. This is OpenCV C++ course that will teach you everything you need to know to get started. This course is based on my previous OpenCV course with Python that now has more than 1 million views and 98.8% positive feedback. Like before, we are going to learn the basics that include processing images, videos, webcams, and even finding shapes, colors, humans, and vehicle number plates. We will also have 3 example projects that will cover all the basics that we have learned. C++ is an excellent language for implementation and creating real-world products. So having this advanced computer skill set on your CV will really make it stand out from the competition. And don't worry, if you are a beginner, we will go step by step right from installation up to creating exciting projects. And our main focus will be practical implementation, so we will skip all the boring theory stuff. I upload videos on a weekly basis, so don't forget to subscribe and hit that notification bell to keep updated. So let's get started. So let's start with introduction to images. So what are images made of? Let's say I wanted to display the number 3. I will take an array of boxes where each box could be filled or empty. So to write the number 3, we would color a few boxes to create that shape. Now some boxes are white in color, whereas some are black. We can denote all the black boxes as 0 and all the white boxes as 1. In this example, we have 10 by 10 boxes. If we wanted more detail, we can increase the number of boxes. In reality, these boxes are pixels. You would have heard of VGA, HD, Full HD, and 4K. All of these represent a fixed number of pixels. For example, VGA is 640 by 480. HD is 1280 by 720. This means VGA has 640 boxes in the width and 480 boxes or pixels in the height. Currently, the image we drew has only 2 colors, black and white. This is known as a binary image. In order to get more detail, we can have an image with more levels. This would mean instead of having only 0 and 1, we will have a range of values. Here we can see the difference between 2, 6 and 16 levels or shades of gray. But still the image is not very clear. So we will be using an 8-bit value. This will give us a resolution of 256, where 0 will be black and 255 will be white. This means we now have 254 colors between white and black. In other words, we have 254 shades of gray. This image is now known as a grayscale image. For a colored image, we have 3 grayscale images representing the intensities of red, green, and blue. In short, RGB. Adding these images together gives us a full color image. This means a colored VGA image is 640 by 480 by 3. In Windows, we are going to use Visual Studio for developing our applications. So we will download the community version. You can just click here and start the download. Once the download has begun, just make sure when you are installing, you use the desktop development with C++. So make sure that this is selected and then you can install. So once that is done, we will go to my website, and in the website here I have listed down all the steps within this course. So the link to this course will be in the description, so you can check all these steps over here. So let's go step by step. So step number 1 is to download OpenCV. So you will click on this link and it will take you to the GitHub page, and in the GitHub page you will click on releases, and over there you are going to click on the exe executable file. So once that is downloaded, you will install it. Now I have installed it in D, so all my path will be containing the drive D. Now if you have installed it in C, then you will have to change your links with the corresponding drive. So in step number 2, you will add your environment variable path. So this is the path that we have to add. So here you can see the process. So you have to double click on path and add this. So let me show you. So we click on this and then we can go to the path, double click on this, and you can see I have added the path over here. Now once that is done, you should restart your computer, and after restarting you will create a new Visual Studio C++ project, and you have to set the platform target to x64. So let's go ahead and do that. So here we can create a new project, and I will use an empty project, and we can hit next, and here I will write the name. So we will call it OpenCV course. So this will open up our project, and now let's go back to the steps. So as it's mentioned here, we have to change this to 64, and then we have to add the directories, and we have to add the library directories and the build directories. So what we can do is we can click on our project, and then we will go to projects and then properties. In the project properties, we will go to VC++ directories, and over here we are going to include the links. So here we have 2 links. So the first one we have to include directories, and the second one we have to include the library directories. So these are the 2 paths that we have to add. Again, I have listed both of them here, so you can copy this, and you can go here. We'll click on edit, and we will add a new one, and we will paste this here and press OK. Then we will go back and we will copy the other one. This is the library directories. we will double click on this, edit, then add it here. Didn't copy properly, we will go back. So we'll click on this and edit, and then we will go to our linker and input, and over here we are going to edit. And if we go back to our step, so add linker input, and we have to type in this OpenCV World. Now this might be different for you if you have a different version, so make sure your version is the same or you use the correct version number here. So if you go back here and you go to edit, you can put it here. Now D is for debugging, and without the D is for release. So if you are using for debug, just write D here. So this file is actually present in your folder, so let me show you where that is. So here we go. So this is the path. Actually I will include this path as well. It is in the bin folder, so you can check the name. You can see here, this is the name. You can check that name over here. So this is the file. So what you have to do is you have to write lib with this. Okay, so let's go back, and now we will go to step number 5, which is testing the code. So we will copy all of this. This is for testing an image, and we will go to our course, add new item, and let's call this test. And over here we are going to paste this, and now we need the resources folder that has this test.png. So we will go back to our course, and over here you can see download resources. We will click on that, and we will click on download resources, and here we can click here to download. So this will download our resources. We can click on that, and here we have the resources folder. So we will go to our project, right click, we will open the folder in File Explorer, and now we can simply paste, or we can drag our resources folder here. So in this resources we have all these files that we will be using within the course. So then we can close both of these, and now it should already link here. Now if you don't see the files here, you can click on this button, show all files, and then it will show you resources and the test.cpp. So let's run this, and there you go. So now you can see we have successfully imported our image, and we have successfully imported the OpenCV library. Now for Mac, we are going to use Xcode to write all of our code. So the first thing you want to do is to go to the App Store and install Xcode, and then we can go and follow the steps on my website. So this is again available on the course page, which is available in the description below. So what you will do is you will go step by step. So step number 1 is to install Homebrew. So you will go to this website, you will copy this and paste here. So here you will copy this link, and you will go to your terminal, and you will paste it here. Now I have already done this, so I will not repeat. Once this is done, you will go to step 2, which is to install OpenCV. So you will write brew install OpenCV. Again, I have done this already, so I will not run it again. Then you are going to create a new Xcode project. So let's go to Xcode. Here we will create a new Xcode project. We will choose Mac OS and then command line tool. And here we are going to use C++. Here we can write the name. So once that is done, now we will add our dynamic libraries. Now to add this, we are going to go back. We are going to right click here and we will click on add files to OpenCV course. Over here we have to go to our folder. To search for the folder, you can click on / and then you can write user local seller OpenCV. So this will open up your current version of OpenCV. You can double click on that and then you can go to lib, and over here you will see all the dynamic libraries. So if it's showing you with icons, you can go to the list, and over here you can sort by kind. So if you do that, then you can select, let me click again. Okay, so here are the libraries, the dynamic libraries. So if you select one of them and then you go to the end till here, and while pressing shift, if you click on the last one, it will select all of them. So now you can add. So one by one, all these files will be added. So next we are going to search for the header search path. So we are going to search for this. We can copy it from here. And we will go to build settings. We will make sure all and combined are selected. And then we will search for header search paths. Here in the header search path, we are going to add this link. Now this is again the same path, user local seller OpenCV. After that you have to write your own version. Make sure your version is correct, and then it should be include OpenCV 4. So I will double click on this side. I will click on add, and then I will paste this, and make sure this is recursive. So once that is done, now we can run our OpenCV programs. But the problem is that it does not allow you to add any image or use any image or camera. For that we need to have access. So here we can enable access to our resources folder. So step number 6 is for that, and step number 7 is to enable the camera access. So let's do the resources first. So as we did earlier, if we go back and we have to go to download, and we have to click on download resources, we can click on this and it will download our resources. So once you have downloaded and extracted your resources folder, now you can drag this folder into your Xcode project. So we will go to Xcode, and over here we will go down and we will click on OpenCV course, right click and show in Finder, and here in the main CPP file we are going to drag our resources folder. Now we can close this, and if we go back to our code, So once we have completed step number 6 and we have added the resources folder, we will go to our test code and we will select all of this and we will paste it in our main CPP file, and then we will hit run. So it will ask you to allow the access. You will say OK, and there you go. So now you can see we have our image, and this means that we have successfully imported OpenCV and we have also allowed the access to our resources folder. So to enable the camera access, we need the property list file. So we need to create a new property list file, and we have to add the camera usage description. So let's go and do that. So first we will go to File, New, and we will create a new file. Then we will go down and select the property list, and here we will call it info, and we will hit create. Now you will see your info.plist here. You will double click it and you will add a new item. The item will be this NS camera usage description. So we will double click and paste this, and the value will be this string over here. So once you do that, you will right click and show in Finder. You will copy this, or you can drag, and then you will go to products and then OpenCV course, and again show in Finder. So this will show you this debug, so make sure this is visible, and then you will go to your previous Finder and you will drag the info plist over here, and now you will close this. So once we have finished the step number 7 of creating the property list, then we will test the code for webcam. So we will copy all of this and we will go to our Xcode and we will paste it here. And now here I'm using 1, but most probably you will be using 0. So this is the ID number, so you can try which one works for you. So if we hit run, and there you go. So this is my webcam. I have put a black tape in front of it, that's why it's showing this. Otherwise you will see the actual image. So you can press stop. If it asks you for the camera access, you will hit yes, and this will work fine. So now you are all set to get started with OpenCV C++. In this chapter, we are going to learn how to import images, videos, and webcams. So the first thing we will do, here we are in our project, and we are going to right click, and you can right click anywhere and you can create a new item, and we will call this chapter 1. So here, first of all, we are going to include all the header files that we require. Now throughout this course we will need only 3 header files for OpenCV. So in one of the chapters we will need one more, but when we go there I will show you how to include that as well. But for the rest of them we will need only 3 files. So we are going to write include, and then we will write OpenCV, and we will first need our image codecs dot hpp. Then we will need OpenCV, and we will need the GUI.hpp, and then we will need the image processing. So include, even though we are not using the image processing for the first chapter, we will still need it for the upcoming chapters. So we will include it now. So image processing, yeah, so there you go. Then we will also include the input and output stream. So input output stream, there you go. Okay, so now we can write our function. So for example, we can write void main, and we don't want to output anything, so we are writing void. So we can start off by writing our path. Now our path will be a string, so we can write here string, but you can see it doesn't recognize string, and the reason is that we have to use the standard library to actually define that this is a string. Now the same thing we have to do with OpenCV functions as well. So for example, if I'm using imRead to read images, I cannot directly use it. I have to write CV, and then I have to write 2 colons. So then it will recognize this function. So to avoid these two things, what we can do is we can write using namespace CV, and we can write using namespace standard. So if we just remove these two now, then it should work without any issues. There you go. So as I was saying, we are going to first define our path. So we will write string path is equals to, and now we need to import our image. So actually, let's write down here that this part is for images. So let's write importing images like that. Okay, so here we are going to define our path. Now to import the image, we will first load it into our project. So we are going to right click on our project name, and we will open up the folder. And once that opens up, we are going to paste our resources folder. Now this folder is available on my website. You can download it from there. So it will have all the images that are required, or all the files that are required for this course. We have a test video, we have test image, we have some for color detection, some for shapes, and then for word perspective and face detection, number plate, and all these files we will be using later on. So for now we will use this test image to import and test our image. So here I can now write resources / test.jpg. Is it JPG? I think it's PNG. Let me check again. Yeah, it's PNG. So we can import it from here, but now you will see that it's not available here, and the reason is because it's hidden. So you can click here on show all files, and then you will see that we have the resources with all these files, and we have the chapter 1. So it's optional if you want to keep it like this or like this. Okay, so once we have the path, now we are going to import our image. So we will say that mat image is equals to imRead, and we will give in the path, and we will put our semicolon. So this will read the image from this path. But what is this mat? This mat is basically a matrix data type that is introduced by OpenCV to handle all the images. So whenever we are talking about images, we will write the data type as mat. Okay, so then we will write imShow to show our image, and we will give it a name, let's say image, and then we can write let's say the image itself. So this is what we want to do, and at the end of the day it will show, but it will close automatically because we are not giving it any delay. So we have to add a delay, so we can write wait key, and here we can write 0 for infinity. So this way, whenever it opens up, it will not close until we actually press the close button. So let's run this. And there you go. So this is an image from one of my videos. So we are going to use this as our test image. So this is how you can import an image. It is very simple and it's very similar to what we have seen in Python. So actually I don't like to write summary here. Let's just remove that and write here images. So now we will do the video part where we will import a video, and to do that we are going to use the same file, which is chapter 1. Normally you would add a new file and you would write the code in that, but I want to keep it simple and add every chapter in just one file. So I'm going to copy this and we will paste it here, and then we will write here video, and this part here I am going to comment. Now this is not the best practice, but since we are learning, this should be more than enough. And keep in mind that any given file can only have one main function. So you cannot have this uncommented and this uncommented as well. So you will have to comment one of them. Okay, so when it comes to importing videos, it's a little bit different because a video is basically a series of images. So we need to iterate through all the images or all the frames and capture them one by one and display them. So for that we are going to use a while loop. So first of all, let's introduce that while loop. So we will say while, and we will write true, and then we will give our brackets. There you go. And then we are going to introduce our video capture object. So here we are going to write video capture, and then we are going to write the name. We will call it cap, and now we have to define the path. So the way we defined it here, the same way we are going to define the path over here. So we can just remove this part and we can bring it on the top, and here we can copy this and paste it here for the path. Now the path of course will be changed because now we are using a video. So we will remove the test.png and we will write test underscore video, I think that was the name, yeah, .mp4. So we will write this, and then of course you have to put a semicolon, and then we are going to read the images one by one, and we don't want to declare it inside, so we will declare it over here. We will call it math image, and then inside here we are going to read our image. So we will say that from this object we are going to read our image, and we are going to store it in this image variable. So then we can display it as we displayed earlier, but this time we don't want to pause for infinity. We want to give it a delay, but for a few milliseconds. So in this case we will go with 1 millisecond, and let's see how that works out. So let's run that, and there we have it. So now you can see this is one of my project videos, and you can see it went really fast. If we want to slow it down, we can write, for example, here 20 milliseconds, and we can play it again. So now you can see it's much slower, and you can see the video. So whenever it finishes, it is going to give you an error because there will be no more images to display. So that's why it gives you an error. Okay, so that is how you can import a video. And now when it comes to webcam, the idea is very similar. So we can copy all of this and we can go down. We can comment this. And here we can write webcam. Now the path is what we have to change. So instead of defining the path, we can simply write an ID. So here we will remove the string, and over here we are going to write the ID number of our camera. So if you have only one camera attached, you can put 0. And for my case, I have multiple cameras, so I'm going to put 1 because I'm using camera ID 1. Now here you have to change it to 1 so that it is not too slow. So let's run this and see what happens. And there you go. So now if I show you my webcam, you can see this is my mouse. We have some Stream Deck, my keyboards, a Raspberry Pi camera lying around. So this is the idea of the webcam. It's very simple. It's very similar to what we have done in the video. All we have to do is we have to define the source. We have to change the ID. Instead of the path, we will give it an ID. So in your case, most probably it will be 0. So I will keep it 0 and I will store it 0 in the code so that there is no confusion. So this is basically how you can import images, videos and webcams using C++ and OpenCV. In this chapter, we are going to learn the basic functions in OpenCV that will help us a lot in creating different projects. So first of all, we are going to create a new file and we will call it chapter 2. Now the thing with these separate files is that you cannot run two files that have the function main in them. So either you have to comment everything out or you have to exclude it from your project. So I like to exclude, so you can right click and you can click on exclude from project. So this way it will go away, but what you can do is you can click on show all files and then it will show again, and if you want it back you can click on include again. So it is not like Python where you can have each file separate and run it. So it is a little bit messy to do it this way. Otherwise you will have to create new projects for each of the chapters, which will be very hectic. So therefore this is an easy hack. You can right click and exclude whatever chapter you don't want to include. So any given time you should only have one chapter running. So right now we are doing chapter 2, so we will exclude chapter 1. So but what we will do is we will copy all of this and we are going to paste it in our chapter number 2, and we are going to use an image, so we will remove all of the video and webcam code and we will uncomment our images. So images code. So here we are going to use the same test image, and then we are going to look at the basic functions that we can use which are present in the image processing. So after reading our image, we are going to first convert it into grayscale. So to convert it, we can write CVT color, and then here you can see that we have all the arguments that are required. So we can write here the input image, and then we have to write the output image or the destination image. So we will write image gray, and then we will write the conversion. So we need to convert from color underscore BGR Okay, now this is giving error because it does not recognize image gray. So what we can do is we can define here matte, and we can write here image gray. So now it should be fine. So if we write it again, color underscore BGR. So OpenCV has the convention of BGR instead of RGB. So it's blue, green, and red. So we will convert BGR to gray. So while you are typing, you will see all the options that you have, and we can click on them. And there you go. So now our image will be converted into gray. So what we can do is we can copy this and we can paste here, and we can write here gray, and then we can write here image gray. So now if we run it, so here you can see we have the original image, and here we have the image gray. So next we will add a little bit of blur. So we have different types of blurs that we can add, but one of the most common ones is Gaussian blur. So we are going to use that. So let's write here Gaussian blur, and then we are going to define our image, then our destination image. Now if you remember, in Python we don't actually write the destination inside the function. You could, but most of the time we write it outside. For example, let me comment this. For example, this we normally write it like this: image gray is equals to CVT color and all of that, and we write it like that. So this is how you normally write it in Python. Now most of the times in C++ we are going to write the destination image inside the function. So just keep a note of that. So here in the Gaussian blur we are going to write image, and then we will write the destination image. Now we will need an image blur, so we will define here image blur, and then we want to define the size of the kernel. So we will write here size, and we will define, let's say 7 by 7. I'm giving it a little bit more so that you can see the effect. And then you have the sigma x and sigma y, so you can leave it blank 0 0, or you can add a value. So let's say we add 5 and 0. So you can play around with these values to see what the effect is, or you can press Control and go to the function itself in the header file, and you can read a little more about it here, and you can follow the link as well here to read more about this. So let's close that, and we will go back to our Gaussian blur. And now what we can do is we can create a new image, a new window for our blur image. So we can write here blur, and we can write here blur as well. So if we run that, now there we have it. So this is the original image, and this is the Gaussian blur image. So if I make this 3 by 3, and let's say I make this 3 as well, then you will see that the blurriness has reduced. There you go. So now it's very subtle, and you can't really tell that if it has been blurred or not. So now that we are done with blur, we will learn how to perform edge detection. And one of the most commonly used edge detector is the canny edge detector. So let's write down the canny edge detector. So canny, and then we are going to give in our image. So we will write image blur. So most of the times when we are using the canny edge detector, we also use a little bit of blur before it. Now this is a common practice. So we are going to use the image blur, and then we are going to write image canny, and then we have two thresholds. So you can see here threshold 1 and threshold 2. So we are going to write the threshold values over here. So here we will write, let's say 50, and here we will write 150. Again, these values you can play around with to find the optimum results. So I can write here image canny because we have not declared it, and then we can run it. Actually, we didn't create a new window, so we have to do that. So let's write here image canny, and we will write here canny as well. Where is it? Oh, it's here. There you go. So this is the canny image, and here you can see that we have detected a lot of the edges, the prominent edges. Now of course you can change the values. If I decrease it, it will give us more edges. For example 25, and let's say 75. So one other thing you can do, which is quite useful, you can create track bars and you can move it to see how much edges do you actually need. So we will learn how to use track bars as well in the upcoming chapters. So once you are done with that, you can come back and use this to actually find the optimum detection. Then we are going to, actually let's stop it first. And then we are going to learn how to dilate and erode an image. So a lot of the times when you detect the edges, they are not completely filled, or you can say they are not joined, or they are very thin to actually detect properly. So what you can do is you can dilate it, which means it will increase their thickness, and you can erode it, which means it will decrease their thickness. So let's see how we can do that. So here we will write dilate, yeah, and then we are going to give in our image. So image canny, and then we are going to give out our image output. So we will write image dilation. So let's add here image dilation and image erosion, or let's write erode. So then we have, as you can see, we have a kernel. So we need to define this kernel. Now in Python, we used NumPy to define our kernel, but here we are going to use the structuring element. So we will use mat, then we will write kernel is equals to get structuring elements, and here we are going to say that we are going to define the type or the shape, which is morph underscore rect. So it is rectangular, and then we will write the size, and we will write the size as, let's say, 5 by 5. So you don't have to go into too much detail of what this does and how it works. All you need to know is that this creates a kernel which we can use with dilation, and if we increase the size of this, it will dilate more. If we decrease, it will dilate less. So we can copy this and we can paste it here, and let's see the result of this before we go to erosion. It is giving an error. Why is that? Dilate, spellings are fine. Image kernel, oh yeah, the semicolon. When you are coming from Python, a lot of the times you will forget the semicolon. Anyways, so then you will copy this and you will write here image dilation, and you will write here dilation. I'm writing the spelling wrong, am I? Yes. It's D-I-L. Dilation. Here also we should write D-I-L instead of D-I-A. Okay, so let's print it out. If you like the video so far, give it a thumbs up and don't forget to subscribe. And there you go. So this is the normal canny image, and this is with dilation. So this is quite a bit of dilation. The thickness has increased quite a bit. Now if we reduce the size, let's say 3 by 3. So by the way, you should use only odd numbers here. So 3 by 3, 5 by 5, 9 by 9, 7 by 7. And there you go. So now it's a little bit lesser than before. So then we can also use erosion. So we can write here erode, and we can write our image dilation as the input and the image erode as the output. And like before, we have to define a kernel. We are going to use the same kernel because we are just lazy. You can actually create a new one if you want. So let's copy this and let's paste it here, and we will write here image erode, and we will write here erode as well. So let's run this, and there we have it. So we started with, where is the canny? Okay, the canny is here. So this is the canny image. So we started from here, then we dilated this image, and then we eroded it. So basically we are increasing the thickness and then we are decreasing the thickness. So these kind of functions come really handy when you are trying to detect the shapes of different objects, and this we will look into the upcoming chapters. Also, we need to change the name here. So these are basic functions. There you go. So these were 5 functions that everyone should know when they are starting to learn OpenCV. In this chapter, we are going to learn how to resize and how to crop images. So what we will do is we will go here and right click on our project, and we will click on add a new item, and over here we are going to write chapter 3. So as I've mentioned before, we need to exclude the previous projects. So we will the previous files, so we will exclude it from the project, and now we can work on our chapter 3. So we can copy the code from chapter 2. So we can select all of it and we can paste it in chapter 3, and we can remove chapter 1 and 2. So most of this we are not going to use, so let's remove all the windows and let's remove all the different functions. And yeah, so now we have a clean code that we can start with. So the first thing is we are importing our image, and now we are going to resize it. So to resize, we have a function in OpenCV that helps us out. So we will write resize, and then we are going to, no, we have to write the correct spelling first, and then we have to write the input image, which is image, and then we have to write the output image. We will call this image resize, and let's declare it mat image resize, and then we are going to write the size we want to change. So let's say we will write size, and what is the size of our image at this point? How can we find that? Okay, let me show you how we can do that. So let's comment this for now, and here we are going to write cout, and we will print out the size. So we will write here image dot size, and let's print that out, and we will add, and we will end our line. So let's run this, and there you go. So our image size is 768 by 559. So we have a width of 768 and a height of 559. So what we can do is, let's say we want a very specific number to resize. So what we can do is we can resize it. Let's remove that. we can resize it, let's say to 640 by 480. So let's run that. Okay, we need to define a new window. So we will call it resize, and here we will write image resize. So let's run that. And there you go. So now our image has resized, and you can see that the aspect ratio has changed. It is not the same aspect ratio. It's squeezed a little bit on the width. So if you don't want to do that, if you don't have a particular number, you just want to scale it down, then instead of using this size, you can remove this and you can define how much you want to scale. So here you have double fx and double fy. So you can define here, for example, 0.5 and 0.5. So this will scale instead of exact pixels. So let's have a look. And there you go. So now it has decreased it 50%. So I mostly use the scaling part because it is more convenient, unless I have a very specific number that I want the image to be. Okay, so this is basically our resizing, and now we will learn how to crop our images, because this is very important. A lot of the times when we find an object, we want to crop it to add more processing on that specific region, and a lot of the times this region is called region of interest, ROI. So to crop an image, we simply have to write, let's say that our new image is image crop. So we can define it here, image crop, and which is equals to, we will define image, and inside we are going to define the values for cropping. So to do that, we are going to use the rectangle data type. So we will write here rect, and then we will define a name. So let's say ROI. And inside that, we have to define the X, Y, width and height. So basically we will write, first of all, let's say 100 is my X, my Y is again 100. And then we have to define the width and the height. Let's say we will put 300 for the width and we will put 250 for the height. So this is our rectangle. And what we will do is we will put this ROI in our image. So this way we can crop our image. So let's see the result of this. So here we will write crop, and here we will write image crop. So let's run this. And there you go. So now you can see that the image is cropped. This is the resized image, and this is the cropped image. You can see I can align it like this. So this point here, what did we write? Let me check. This point here is 100. So this point is 100 and 100. And then from 100, we are going 300 pixel forward and 250 downwards. So let's try to find my face. Let's try to crop it. So if this is 100, maybe this is about 200, and we will keep the height same. So let's put 200 here. So let's try that again. Yep, and maybe a little bit down. So if it's 250, let's make it 300. Let's see if it crops. Yep, there you go. So now you can see that we have successfully cropped my face from the image. Is it aligned? I can align it from my shirt over here. There you go. Maybe a little bit to the left. A little more. I think, yeah, that is pretty much aligned. So that's how you can crop the image, and that's how you can resize it. So let's rename this to resize and crop. In this chapter, we are going to learn how to draw shapes and how to write text on images. So we will learn how to draw circle, rectangle, line, and how can we put text on different images. So we will copy our chapter 3, which was about resize and cropping, and we will create a new chapter. So we will right click and we will add new item. We will call it chapter, is it 4? Yeah, chapter 4, and then we will paste it, and let's change this name to draw shapes and text. And then we can remove these images, and yeah, let's remove pretty much everything. Yeah, we are not going to use any image. We are going to create our own image. So that is also quite useful when you are creating different projects. Sometimes you want to create a blank image of different colors. So let's see how we can do that as well. Okay, so, and one more thing, that we have to remove chapter 3 from our project. So we will right click and exclude from the project. And before we do that, we will save it and make sure that this is on. If you have this on, then you can see all the chapters and you can see all the resources files. If you have it off, you will not be able to see it. Okay, so in chapter number 4, we are going to create our own blank image. So let's write here blank image, and here we are going to define mat, and we will call our image img. Now we have to define the size. So let's say 512 by 512, and then we can define, for example, the type. Here we can define the type as CV underscore 8-bit. 8-bit means that each pixel will have a value from 0 to 255. Because if you're not familiar with bits, bits are basically based on the power of 2. So 2 to the power of 8 is basically 256 values. So you have a range from 0 to 255. But you don't have to go into that much detail. But all you need to know is that 8-bit means you have a range from 0 to 255. And if it is unsigned, then it will be 0 to 255. If it's signed, then it will be from -127 to 127. But here we are going to say it is unsigned, and the channels are 3. So we need 3 color channels, BGR. So that's how you define this. And then we are going to write the color that this image will have. So we can create a black image, we can create any color that we want. So normally whenever we will define color, we will define it as a scalar, and then inside we will write our BGR values. So if I want blue, I will write 255, 0 and 0, and this will create a blue image. So let's run this. There you go. So this is our blue image. And let's say if I want purple, I can write 255 here, and that should give me purple. I usually prefer this purple color when I'm creating bounding boxes or writing any text. That's why I know this is 255 and 255. Anyways, so in this example, we are going to create a white image, and we will put on top of that. If you want to create black, you can put 000. Okay, so now we are going to create a circle first. So we will write here circle, and we will give in our image, which we just created. And now we have to define the origin point, which is the center. So for that, we will write point, and then this is the data type point, and then we are going to write the center point. So let's put it at half of this, which is 256 and 256. And then let's define the size of the circle, let's say 155. And let's define the color, scalar. Again, we are defining color, so we have to write scalar. Now I have already tried this out, so I want to add this specific color of orange. So that's why I'm using this color. You are free to use any color that you want. So if we do this, it should be more than enough to create a circle. So let's see how that works out. So this is our image, and this is our circle within that image. Now if we want to increase the thickness of this, we can write here, for example, 10. So this is the thickness. If we run it again, and there you go, now the thickness has increased. But what if we want it filled? Then we can simply, instead of thickness, we can write here filled. So let's run it. And there we have it. So now our circle is filled. We will keep it like this. So now we will draw a rectangle. And inside that we are going to define our image first. And here we have the option of defining a rectangle like we did in chapter number 3. So here we have the rectangle option. So we will have X, Y, width and height. Or the second option is to define 2 points. So if you write it as points, then it will be the bottom top left corner and the bottom right corner. So this will be XY, and the second one will be X1, Y1. So it is not the width and height. So let me show you what I mean. So if I write 130 and let's say 226, again I have tried these values out before, so I'm putting these exact values. So 382 and then 286, and then we can write scalar, yeah, and we can write 255, 255 and 255. We are going to use white color, and we will put the thickness of, let's say, 3. So let's run this. There you go. So this is basically my point here, 130 to 26, and this point here is 382 and 286. So these are points. But if I write rectangle, then it will be the width and the height, not the actual points. So it is up to you what you want to use. Both of them should work fine. And for this case we are going to fill it. So let's write it filled like we did with the circle. And there you go. Now it looks like a stop sign. So let's move on, and now we are going to draw a line. So to draw that, we will simply write line, and we will give in our image, and then we will write the point. The point is basically the starting point and the ending point. So we can write 130 and then 296. Then the ending point will be 382 by 296. So it will be a horizontal line. Then we can write again the color. So scalar, and we will write again the white color, 255, 255 and 255. Thickness, let's put it as 2. So let's try that out. And there you go. So now we have a nice line right below our rectangle. Again, if you change this value, it will not be horizontal. Let's say I put 450. Now it will go down. There you go. So it's going this way. So again, you can change these values, you can play around with those to find out what design do you want. So the last thing we will do is to put the text. So we will write here put text, and again we will define our image, and then we will define what we want to display. So let's write my channel's name, Murtaza's Workshop, and then let's write the points is 137 and then 262. So this is basically the X and Y, the starting point. And then you can define font. So we can write here font, and you will see that we have a lot of different fonts that you can select from. Let's just pick a random one, and here we can define the scale. So let's say I put 2 as the scale, and then we can define the color, scalar, and let's pick the orange color over here. Let's copy that, paste it here. And at the end you can also define the thickness. So let's put as 2 as well. So let's run this. And there you go. So now you can see the text is displayed, but it is quite huge. So let's reduce this to 0.75. And there you go. So now it perfectly fits within that circle and it looks quite good. Now let me show you what the thickness means. So if I put let's say 5, which will be crazy, but still let's try it out. So there you go. The text becomes really thick and it now is quite hard to actually read. So let's keep it as 2 because that was good enough. So this is how you can create a blank image of any color. Then you can add a circle, rectangle, and a line along with some text. So this comes very handy when you are detecting objects. So you can create bounding boxes, rectangles around them, and then you can, for example, display what size is the rectangle, what is the name of the object. So all of these things you can define on your image. So it will be very useful when we do our projects. In this chapter, we are going to learn how to warp images. Now, if you are not familiar with warp, then let me show you. This is the image that we will use. It is of a few cards. And what we will do is we will take these 4 points, 1, 2, 3, and 4, and then we are going to display them as if it was taken from the top. So it will be like a bird's eye view. So that is basically what warping is. So let's see how we can do that. So first we are going to go to our project, right click, add new item, and we will call this chapter 5. And over here, first we are going to exclude the chapter 4, and then we will copy the code from chapter number 1 because we are importing an image. So let's paste it here and we will comment it out. Here we will write warp images, let's say, and then we will import our, was it called, cards.png or jpg? I think png. Let's run that. No, it's jpg. There you go. So this is our image, and we are going to, so you can select any of these cards. Now I'm going to do this king card. I recommend you to do after that, try out to get the jack, the 9, and the queen. So what is the idea behind this? First of all, we have imported our image. Now we need the points that we want to warp. So if I open this image in Paint, right click and edit. If I open this in Paint, then when I go to this point, it will tell me at the bottom of the screen, it is going to tell me what is the pixel value at this point. Not the pixel value, what are the coordinates of this point, of this pixel. So here you can see it is 529 and 144 pixel. Then over here you can see it is 405, 392. So I have noted all these values down, and we will write them here. So here we are going to write points, but the function that we are going to use actually requires floating points. So we are going to use 2f instead of just points. Then we have to define the name. So let's call it source, and we will define the size of it. So we will have 4 points inside of it. So let's create our points. The first one will be 529 and 142. Then the second one is 771, 190. So these are the points that I've already collected from our image, 405 and 395. And then we have 674 and 457. So these are our source points, and then we will have our destination points. So destination points will be basically a rectangular image. So we have to define that what does this point correspond to. So this point corresponds to 0, 0. So this point over here, let me bring a circle. So this point over here should be if let's say this is my card, so this point over here should be this point, 0, 0. And then the second point should be this point. Then the third will be this, and the fourth will be this. So these are the corresponding points. So we have to define it. So here we are going to define that this should be 0. So we cannot just write 0 because we have to have floating values. So we have to write 0.0f. And then we will write that this is the width. So this is the second point. So it will be the width, and in the height it will be 0. So this will be width and 0.0f. Then we will have 0.0f and height, and then we will have width and height. So what is this width and what is this height? So this should be the size of our card. Now I have noted down the size of cards. So they are 2.5 by 3.5 inches. So what we can do is we can keep the same aspect ratio. So we can define here that let's define it down. We can define here the float width is equals to 250 and the height is equals to 350. So now we can use the width and the height over here. So these are our source points, and then we have our destination points. Now we can use a transformation matrix to actually find the warp. So in order to transform, we need a matrix. So whenever we input the values, whenever we input the points, it will output the corresponding transformed points. So we need that matrix. So let's say this is our matrix is equals to, so we need to define it. So we can define here matrix, and we will also need our image warp. So let's define it here. So yeah, that should be good. And then we can define here get perspective. Am I writing the spelling wrong? Yes, perspective transform. So here we are going to input our source points and our destination points. So this will give us a matrix that we can input some values, and in the output it will give us the corresponding values. So then we are going to use verb perspective. Again, I'm writing the spelling wrong. Verb perspective image, then image verb, and then we will write the matrix that we just found out or created. And after the matrix we have the size. So we are going to give in a point, and we are going to define the width and the height. So this width and height will be basically the width and height of our card or the final image. So now what we can do is we can simply plot, or we can simply display our image. So here we can write image verb and image verb. So let's run this, and there we go. So now we have this image straightened out, stretched, as if you are looking from the top view. The same thing you can do with the queen and the 9 and the jack, and in fact you should do that as an exercise to do some practice. Now one more thing we can do over here is to create circles around the points that we have selected. So we can use these points and we can create circles on them. So to do that we can write here for integer I is equals to 0, then I is less than let's say 4, or we can take the size, but let's just keep it 4, then I plus plus, and then we can write our loop. So what we can do is we can use the circle command. So let's just stop this first. So the circle we did in chapter 4. Yeah, so in chapter 4 we have this circle. We will copy it from here, we'll go to chapter 5 and we will paste it here. So here we have to just change the point. So we will say that take the point from our source at the value I, or the element I, and then this 155 is just way too big, so let's just put 10, and the color let's put red. Okay, so let's run this, and there you go. So now you can see we have selected these points. So this is a nice way to know if you are selecting the correct points or not, if there is an issue or not. Now the reason we are doing it after all of this, you might say, why don't you put it up here before we actually do the verb? The reason is that then the circles will appear in the verb as well. So there you go. So at the edges you can see the circles, they are appearing. So that is not good. So therefore we are putting it down after the verb perspective. Okay, so this is how you can do a verb of an image. Now in the upcoming projects we are going to use this technique to actually scan documents. So if you have used any mobile app that actually detects a paper or a document, and then it creates a bird's eye view and does some scaling to it and then some processing to make it look like it has been scanned. So all of this we are going to learn how to do that in the upcoming project. So in this chapter we are going to learn how to detect colors in images. So you can use this to create an object detector of a specific color as well. So first of all we are going to go to our project and we are going to add new item. We will call it chapter 6, and we will copy, what should we copy? Let's copy chapter 1 and we can close chapter 1, 4 and 5. Can save that. Let's paste it here and we will uncomment this. Here we can write color detection. So we are not going to use the test image, instead we are going to use Lambo, which is the image of a mini Lamborghini. So let's exclude this from our project, chapter number 5, and now we have only chapter 6 running. So let's run this and see if it works properly. There you go. So we have our image, the orange image. So basically we are going to detect this orange color. By the way, you can write here integer. The common or the standard practice is to write int and then you return 0. Return 0. But since it's a very simple code, we can simply write void. It doesn't make much of a big difference. Anyways, so now we are going to convert our image to HSV space because it is much easier to find the color in the HSV space. You can read more about this color space. It is basically hue, saturation and value. So as we did earlier in chapter number 2, we saw that we can convert CVT color image, then we are converting our image. So we can copy this or we can write it again. So CVT image, and then we can write here image HSV, and then we convert this BGR to HSV. Now let's create this image. So we will write here mat and let's write our image HSV. Then we are going to print it out. So let's write ImShow and then image HSV, and then we will write image HSV. There you go. So let's see how it looks like. Okay, so this is our original image and this is our HSV image. It looks a little bit odd, but trust me, it will work out at the end of the day. Okay, so once it's converted, we are going to use the inRange function to actually collect our color. So we are going to write inRange and we will write the image HSV. So we will write that this is our image, and then we will define a lower limit and an upper limit. Now usually you can define exactly what color do you want. For example, I want red color, I want yellow color, but in reality, because of the lighting and different shadows, the color will not be exactly one value. So it will be a range of values. So it is always good to use that range. So we will have a range with lower and upper values. And then the output will be our mask. So we will call it, the output image will be our mask. So we need to define the mask. So this will be our new image. And then we also need to define the lower and the upper limit. So we can define here scalar, because it is just 3 values. So we can define lower as H minimum. So this is the hue minimum. And then we have saturation minimum. And then we have the value minimum. Same way we are going to have max. So let's copy that and write here upper. And instead of minimum, we will write max. Now these values, you can hard code them and you can write them directly here. The other way that what I prefer is to write here integer h minimum is equals to, let's say, 0. Now this color I have already picked out and I know what exactly this color is, so I'm writing those values over here, but I will later show you how to find a different color as well. So let's put this here, and then we can write s minimum is 110, then v minimum is equals to 153. Then I'm writing it in a new line because we are writing maximums. So max is equals to 19, then s max is equals to 240, and v max is equals to 255. So now if we print out, or if we display our image, which is basically the mask, we can write here mask. So let's see how that looks like. So there you go. So this is our original image, this is the HSV space, the color space, and this is our mask. And you can see that we have detected the orange color perfectly, as you can see over here. But the question is, how did I find these values? And a lot of the times you might want to use your own values. So how can you do that? Now the thing is, because there are 6 values involved, changing all of these every time and running it again will be very painful, and it will take a long time. So what we can do is we can create track bars which will allow us to change these values in real time, and then we can find the minimum and the maximum values. So how can we declare this track bar? So OpenCV has a built-in functionality for this, and whenever we are using track bar, we will have to use a while loop. So we are going to create a while. So we do not need to convert or import it again and again. So we will create a while after that. So we will write here while true, and then we are going to close this here, and we will change this to 1 like we did in the video and webcam. We will change this to 1, and over here again we do not need to create the track bar again and again, so we will create it outside the while loop. So we will call it named window, and our window name will be track bars. Let's keep it small, track bars, and you can define the size of this. So let's say 640 by 200. So this will create our track bar. So if we run this, you will see a new window. So this is our track bar window, and now we can create track bars inside of this. So here we will say create track bar, and we will give the value a name. So let's say this is hue minimum, and then we will say this is inside, this should be inside the track bars window, and then we have to give the address of our value. So here this is the h minimum, so the address of that will be and h minimum, and then we will give it the maximum value. So the maximum value will be 179. So for hue it is 180, and for the other two, value and saturation, it is 255. So what we can do is we can copy this. Actually, let's run it and see if it creates. So here you can see this is our hue minimum. So if I change this, it should change. Yeah, so you can see now it has an effect in real time, because it is already linked, because we are using the h minimum here, and then we are using that in our lower. So what we can do is we can copy this and we can paste it 6 times, and here we will do, let's say, max. Let's copy max and we will paste it here, and then we can do hue saturation, so we will write here sat and then val and then val. So here it should be max, here it should be S and max, here it should be V and V max. So 255, 255, 255 and 255. So these are the changes. Again, these two will be 179 and these four will be 255. So let's run this again. And there we have it. So in the beginning it should be like this. So minimums should be at 0. So 0 and 0, all three are 0. And then maximums should be at 255 and 179, 255 and 255. So it should be like this. Now we can move these track bars to find our color. So we will move this around and we have to keep it white. So we will change it so that it remains white. So here you can see. Then we can go to the next one. You can see it becomes more clear. We can reduce now. Then we can check the value. Yeah, getting a little bit better. And there you go. So these are the values. Once we have these values, we can go back and we can enter these values as our starting points. So here we can write 4, then here we can write 24, then 145, 255, 117 and 255. So that's how you can change. Actually, let me show you another example. I have another image of shapes. So this shapes.png, let's bring that in and let's pick one of these colors. So shapes.png, and by default this should be 0 0 255 255. Oh, this should be 179 179. Okay, so let's run this. So this is our blank mask. So now we can let's pick one of the colors. So let's pick this red, or let's pick this purple, because this purple, so we can keep moving until this one is in the picture and the rest are gone. So we'll go till here, then we will start reducing the others, and there you go. So this is very simple because we are using definite colors. There is no variation in these colors, so it was very easy to find. Then if we want to, for example, the green one, let's try that. So we will keep moving it until the green one stays and the rest are gone, and there you go. Because there is no change in value and saturation, therefore we can only play around with these and we can find that. So this is how you can find colors in different images, and based on these color detection you can detect different objects, and this is a very fast method to do object detection and tracking using color. In this chapter we are going to learn how to detect shapes or contours in images. So we will be able to detect rectangles, squares, triangles, circles, and all these different shapes. So let's get started. First we are going to right click, add new item, and we will call this chapter number 7. Now we will remove chapter number 6. We will exclude that from our project, and we can copy from chapter 1 because we will be using an image. So we can copy from chapter number 1 and we can paste it here. We can uncomment this and we can change this to shapes. So if we run this, that should output our shape image. There you go. So these are the different shapes that we will be detecting. Okay, so the first thing we will do, we have to pre-process this image before we find contours or before we find the shapes. So the idea is that if we find the edges of our image, then we can find which shape is that edge or which shape is that contour. So what we will do is we will use the canny edge detector to first find the edges, and then we will find the contour points. So if you did not understand it right now, don't worry. As we go along, I will explain every bit. So in chapter number 2, to use the canny image, we first did the conversion to grayscale, and then we added the Gaussian blur, and then we used the canny edge detector. So we are going to copy all of this and we will paste it in chapter number 7, and we will also paste the declarations over here. So we can paste it here. So image gray, blur, canny, dilation, and erode. So for now we are only using these 3, and maybe we will use dilation as well. Let's copy that as well. So where is dilation? Okay, so we can copy this as well. There you go. So let's see first of all the gray. So we can copy this, we can paste it multiple times, and we can say image gray, then we can say image blur, then canny, and then dilated. So then we will change it image gray, image blur, image canny, and then image dilation. So let's run all of them and see one by one what are the results. So there we have it. So this is our original image, this is our gray image, this is the blur. Blur is not being applied on this. Okay, let's go back. So here we are applying the blur on the wrong image, so we will put here image gray. In fact, we should do the same in chapter number 2 as well. We should use image gray. So let's run it again. So this is the original image, then we have the gray image, then we have the blurred image, then we have our canny image, and from the canny we have our dilation image. Now if you see here this triangle, and if you look at the edge of this triangle, you will see that it has a small gap. So when we dilate the image, this gap is gone, and now it is a solid line. So this means that our detection will be much better with the dilated image rather than the canny image. So that's why we are using dilation as well. So all of this is basically pre-processing of the image. So we can call it pre-processing. Now once the image is pre-processed, then we are going to find the contours in it. Now what we will do in this chapter will be a little bit different than what we have done before. So we are going to introduce a new function to find the contours. Instead of writing everything in the main function, we are going to introduce a new one. So over here we are going to define our new function. we do not need anything coming out of it. There will be no returning value, so we will write void, then get contours, and then later on we are going to decide what are the things that we need. But for now we are going to write here get contours, and we will write it like this. So first of all, we need to send in our image. So this is the last image that we have, so we need to send this. So we will write here that we are sending image dilation, and over here we need to receive it, and we have to define the data type first. So we define it as mat, and then we will write that this is our image that we are receiving. So this is the receiving image. Let's call it image dilation. And then we will also receive another image, mat image, on which we want to draw. So we can write here that this is the image that we want to draw on, and this is the image that we want to find the contours on. So then we can write here, first of all, we can write the function find contours. So we will write here find contours, and let's see what is required. So the first thing is the input image. So we will write here image dilation, and then we have our contours, and then we have our hierarchy, and then we have our type, our method. So we are going to use the external method. You have a lot of different methods that you can use. So external, flood fill, list, tree. So you can use any of these methods. We are going to use external, and then we have the chain approximation. We can use the simple chain approximation. Now you can read all about this in the documentation, and you can if you don't want to read about it, you can play around with these values and see what the effect is, but we are not going to go into the detail of the theory for these parameters. So we are getting these errors because we did not define them, so we have to define our contours. Now unlike Python, we need to define the data type over here before we can define it. So what will it be like? So these contours will be a vector, and inside that vector it's like a list, and inside that list there will be another list of different points. So let me show you how that will look like. So this is a vector, and inside that vector we will have more vectors. So these are more vectors, and for each vector will be a contour, and each contour will have some points. So this will be, let's say, point 1, let's say it's 20, 30, and then we will have point 2, let's say that is 50, 60. So this will be one contour, and then there will be another contour, then another contour. So this structure is basically, we have a vector, and inside that vector we also have a vector, and inside that vector we have points. So inside this vector we have different points. So point 1, point 2, point 3, point 4. So the data type inside that is points. Sorry, point. And then we need to close this, and then we can write contours. So we can remove all of that. And for the hierarchy, the data type is a little bit different. It is basically a vector, but it has 4 integers inside of it, and OpenCV has their own data type for this, so we will use that. You don't need to go into that much detail for this because we are not even using the hierarchy, so you don't have to worry about that. So we are basically writing vector for I, which means it has 4 integer values. So we are going to write here hierarchy. Let me just copy the spellings. There you go. So now we will be able to find these contours, and what we can do is we can print them on our image. So to print them, we have to write draw contours. So this is the function that comes with OpenCV to actually draw contours. So let's write that down. So we will write here draw contours, and then we are going to write which contours are we talking about. But before that, we need to write which image we want to draw on. So this is our image, and then we are going to write which contours that we want to draw, and we can also define which contour number we want to draw. But in this case, we want to draw all of them, so we will write -1. Then we can define the color, so scalar, and we will define, let's say, purple. As I've mentioned before, that is the one I usually choose, and then we will give it a thickness of 2. So let's run this and see if it works properly. By the way, we can remove all of these because we have already seen the results, and then over here we can write im show. Actually, we already have that, so it should display. Let's see. And there you go. So on our original image, it has drawn all the contours it has detected with purple color. So we can change the thickness here. For example, here we can put 10. It will be really thick. There you go. So now you can clearly see the difference. Okay, so now that we have the points, the contour points, what we want to do next is we want to find out the area of these contours, and we want to filter out. So right now there will be no filtration because we do not have any variation. In fact, let me introduce some variation. So let me close this, and I will go to my image, right click here, edit, and let's put something very small. So let's put something like this, and let's save this, and let's run it again. So we are assuming that this here is noise, so we need to remove this. Now in order to remove this, you can simply add a filter for area. So if the area is above a certain value, then it should detect as an object, otherwise, or a shape, and then it should use it as that shape. So first of all, we will loop through all the contours that we have found. So we will write integer I equals 0. We are creating a loop, and we will write I is less than contours dot size. So while it is less than that, it will keep adding to I. So then we are going to find the area of each of these contours. So we will write here area is equals to contour area. So this is the function that actually helps us find the area. So we will write here which contour are we talking about. So we are talking about the ith contour, and this is giving an error because we did not declare. So we can write here, for example, area will be, I think, integer. So we can write here integer area. So we can write here, and then we can print this out. So we will print out our area, and we will end our line. Okay, so let's run this. And there you go. So these are all the areas that we find, and you can see that we have one very different, which is 185, and most probably this is 185. So what we can do is we can create a filter where we can say that it has to be above at least 1000. So we can say here that if area is greater than 1000, then we will perform the next steps. So right from the start, we can remove this draw, and we can draw only the ones that are above 1000. So instead of writing -1, we can write I. So it will draw one by one all these contours, and it will not draw the ones that are below 1000. So if we run this again, there you go. So now you can see the purple line has been removed from our image. So here 185 is removed. Okay, so now that we have done the filtration of area, next we are going to find the bounding box around these objects or shapes. So to do that, we are going to find the parameter. So we will write here pari, and then arc length. So we will find the arc length using the contours, and we will give in our contour. And then the boolean is basically whether this object is closed or not, whether this parameter or the contour is closed, and then we will say yes, it is closed, true. So that should give us the parameter, and we did not define parameter. It should be float. And then we are going to write then we will find the corner points or the number of curves that this polygon has. So we can say that if the polygon has 4 curves or 4 corner points, then it is a rectangle or a square. If it has 3, then it is a triangle. If it has a lot, then it is a circle. So what we will do is we will write approx poly dp. So we are going to find the approximation of the curves. Again, we are going to say that we need to find for our contour the ith element, and then we are going to define a new array in which we will send all these values. Okay, so we need to have an array which will have all the updated values that we will use. So we will call it contour poly. Okay, and it is an array as well, or it is a vector. So we are going to have a lot of different values. So we will choose the ith value, we will send it to that. So basically this is the output. And then we are going to use a random number multiplied by the parameter. Now here, if you don't understand this part and you don't want to do it, you can remove it as well, and you can put here a fixed number like 3 or 5 or something like that. I recommend that you use this method instead because it is a little bit better. And then at the end we are going to write true again for our boolean, which means that if it's closed or not. So we will say that it is closed. So it is giving us an error because we did not declare this. So let's declare this at the top. So here we are going to say that this will be exactly like our contours, but it will not have all the points, it will have only the corner points. So if it's a rectangle, it will have 4 points. If it's a circle, it will have maybe more than 6-7 points. If it's triangle, it will have 3 points. So we can copy this type and we can paste it here, and then we can write that this is our con poly, and we can actually define the size of it as well, because we already know what the size of it will be. It cannot exceed the number of contours, so it will be exactly the same size. So we will write here contours dot size. So this should remove our error, and there you go. So now we can draw only these points as well. So instead of writing contours, we can write con poly, and then we can draw the ith contour. So let's try this and see what happens. So there you go. So now it's drawing all the points that it thinks it has found. So based on these points, so here you can see it's not drawing the complete circle, it's drawing these points, and in between that it's drawing the lines. So this rectangle will have only 4 points, and then it's drawing the line between them. So what we can do now is, if we check the length of any of the con poly, that will give us the approximation of whether it's a rectangle or a square or whatever it is. So we can write here, for example, the con poly at the ith element, and we can find the size of it. Oh, sorry, this should be a dot. So let's put C out, and let's put an end here, and let's print it out. So now we can see that the first one it has found has 4, then the second one, maybe it found this one, which is 8, then you have 3, which may be this one. So all of these are now the number of points, or the number of edges, or the corner points it has found. So we can say if it has found 3, it is a triangle. If it has found 4, it is a square or a rectangle. So one more thing we can do is we can find the bounding box around it. So if we want just a rectangle, we can find that around it. So how can we do that? We can do that by writing, let's say, bounding box, or is it yeah, it's bounding rectangle. So bounding rectangle, and we just pass in our contour poly. So this is the approximation that we got, the number of corner points. So we pass that in, and it will draw a bounding box, or it will give us the coordinates of the bounding box around it. So what we can do is we can create a new vector to store these values. So we can write here vector, and inside that we can store the rectangle values, and we can call this bound rect. So just make sure that you understand the difference between bound rect and bounding rectangle. Bound rect is the variable that we are introducing, the vector, and bounding rect is a function that we are calling to find the bounding rectangle around it. Okay, so don't confuse between that. And because we already know the size of the vector, so we can define it from here, contour size. So now we can put all of these values in our bounding rect, and we can put them in our vector. There you go. So we could print it out as well, and then we can draw these as well